This might work. Let's see. I don't know. I don't like that. Let me see. It's coming. Somebody's coming. And my spidey sense go off. Okay. That'll work. Man, this room is weird. This is what I did. Just trying to make sense of this room. Okay. I can't. Did we not do this the first day? If I divide two things with powers, what do I do with the powers? Subtract, right? So what would this be? X to the 0. What is something divided by itself?
1.
All right, so x to the 0 is 1. So if I just, real quick, go with me. If I write an x, what's in front of the x? What's understood to be there? 1. So if I said write the same thing but don't write any x's, what would you write? 1. So x to the 0 just means no x's. So then what's the only thing there? 1. Not 0. 1. Everything I just said. Okay. Right, there's a 1 there. So if I take away the x, if I have no x's, then what's left? 1.
Okay.
Here's another way. What happens, what's the only number I multiply something by and the thing stays the same? 1. If you multiply something by 1, it stays. Is there any other number that I multiply by and it stays the same? Hell no. What is x to the 0 times x to the 7th? X to the 7th, you add the powers, right? Did the thing stay the same? So then, therefore, this must be 1. Do you guys, so
Yes.
those are several different proofs of something to the 0 power is 1. I like it. So in that problem where it says x to the 0, you just replace it with 1. So be careful. What is this then? Is that 1?
No, that's 3. 2.
It's not adding, it's multiplying. So it's 2 times 1, 2. How do I make it 1? I would do this. What's this? Well, I just told you. Anything to the 0 power is 1, so that is 1. I used to do this. I don't do this much anymore, but I used to do this big, I make this big, ugly, crazy thing, and then I put a 0. So, 1 done, right? People are like, oh, God, no, just this 1. It's a little evil, so kind of mellow it out. Maybe? No? You guys are like, man, it's too early for this. You signed up for it. Yes?
For 66, do we like factor each?
Oh yeah, so we're going to do that today.
Okay.
So today we've got to finish talking about factoring. That's the next step right after that.
Okay.
So today my plan is to finish the factoring discussion, talk about rational expressions, talk about radical expressions, totally, and then maybe do a little bit from chapter 2, and we'll see if we get that far. We'll just see. Okay. All right, yes?
For like number 34, how do we square root it if it's like cube?
Oh, cube root.
Oh.
So, again, we're going to talk about radical expressions today. But let me ask you, maybe it's a nice segue to this. I'll do a little preview. Can somebody tell me what the square root of 25 is? 5. I love it. Why? I love it. I love the way you said that. Well, because, Jeff. So we understand. All right, now listen, this is really important what I'm about to say. Throughout history, math people, we don't like to write a lot. Personally, it's because I can't do it well, right? So what we decided to do is we decided to make a symbol that would mean an entire question. So we have internalized the question this asks. Can somebody tell me the question that a square root symbol asks? You guys know this. Why is the answer 5? Why is the answer to this 5?
Because it's half 25 multiplicative.
Very beautiful. More basically, the square root symbol just asks, what does it take 2 of to multiply to be 25? Right? So what is a cube root asking you?
What does it take 3 of?
What does it take 3 of to multiply to be 8 in this case? So of course, what's that?
2.
2. 2 times 2 times 2 is 8. I love it. Crazy sauce. So what's wrong with this? What's kind of wrong with this question, if I say, I need an answer, I need you to do something, and you can't use a calculator, why on the surface of that is that a mean question? Not a perfect square. There's no number, all right, let me say it this way. There's no rational number times itself equals 50. What's really close to 50 that would work? Square root of what? No, oh, I see what you're saying. But what's close to 50? 49. So we can estimate, what's a good estimate for what this answer is? You can do it. Square root of 49 is 7. So what's a good estimate for square root of 50? 7.1. Kick ass, right? And if you want to, you can throw it in the calculator, see what it says. Who cares? Now, I like what you just said. Can't I break this up into square root of 25 times square root of 2? Is that still true? Right? Because as long as it's got the root on it, you can multiply those things together. And we know what the square root of 25 is, don't we?
Yes.
5. What's the square root of 2? I don't know. So that's the answer. Okay. So I call that reducing the radical. Does that make sense?
Mm-hmm.
All right, let me show you. All right. For just a quick note. The beginning of this class is always interesting for me, and I want to make sure you guys understand this. The first 2 chapters are chock full of every damn thing. I don't know if you've noticed this. Things are going to settle down when we get to chapters that are a little more focused. I'm going to sort of like jump around a little bit because there's just a lot, right? Now, in the process of talking to you about that, oh, there it is. I was going to say I forgot what I was going to do, but now I remember. Just go with me for a second. How do I reduce, how would you reduce this? You could do it, Jeff. You can do it, buddy. You could so do this. You could do it, write something. There it is. Okay. How would you reduce that? Because what does this, of course, want you to do? It wants you to divide it, correct? If you divided this, would you get a nice number? No.
You have to take
So then we're like, no, let's not do that. So what can go into both?
4.
Even more. 8. 8 times 5 over 8 times 3. So I do what I can do, correct? I really want this to make sense. I do what I can do. There's what the division wants. I can divide those. And then I leave what I can't do, correct? Maybe? So watch this. Can you do the square root of 8? Not directly. There's no nice number that you can multiply by itself to get 8. Does everybody agree with me? If you think there is, tell me, teach me. There isn't. Okay. But is there a part of this I can do the square root of?
Yes.
So I can break it up like we did this. The same idea. I break it up into a part I can do times a part I can't do. And then remarkably enough, I do the part I can and I leave the part I can't. Exactly what we did. And we did the part we could and we left the shit we couldn't. Right? So then square root of 4 is 2. Square root of 2, I don't know. Done. So if you put square root of 8 in your calculator and you put 2 times square root of 2 in your calculator, same number. 2.828, blah, 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 blah. Okay. I like how y'all are just going to trust me. I like that. Okay, good. Is that all right? I sort of went off on that a little bit. The minute I say anything and it doesn't make sense, let me know. You know, like, everything after hello. Anything else from homework or anything? Yes?
So for the answer for that one, like, can you leave it like that, where you can put it in decimal form and either way is right?
This. I will almost never want you to put that in the calculator because then that's something else doing the work for us. Now, real quick, if this was a word problem and it said how far away is Tom from his house? Ain't no way, Tom's, I'm about 2 times the square root of 2 miles away from you. So if it's a word problem, go ahead and throw that sucker in the old calculator, correct? Because nobody's going to say this. How much do you weigh? 100 times the square root of 3 pounds? Go away, right? I don't want to talk to you. Okay. Does it make sense? So if it's just a pure math problem, I almost never want you to give me a decimal because I want you doing the work, not your calculator. Okay. But don't worry, you will be able to use calculators. Okay. Not all the time. Anything else from homework or general?
How do you provide like a fraction, like a fraction?
Yes.
A fraction over a fraction, like on number 7.
Oh, sweet. I call it fracception. Which one is it? 70. Oh
Last
wow.
one.
The projector just woke up. Can you guys see that? Oh yeah. Oh yeah. Okay. We are going to discuss rational expressions today. This one's a little bit of its own creature. So let me kind of build up to that. Like where that is. Give me a second. Just trying to make this room work for me. All right, bam. There it is. Okay, so how would I do, let me start off kind of nice. How would I do this? Anybody know? Let's write that better. That sucks. What's a better way to write? What's another way to write divided by? Oh, all right, I got you. But another way to write divided by is just using the symbol, right? Those mean the same thing, yes?
Yeah.
Now, I multiply by the reciprocal, correct? Does anyone know why the hell we do that? Does anyone know why we do that? Because this is how you would do this problem. You would say 2/5 times 9/4. I wouldn't just multiply, I would cross, reduce.
Is there a saying?
There's all kinds of sayings. I don't know what it would be, sorry. All right, does that look familiar? You guys, hopefully everybody here knows how when you divide fractions, you multiply by the reciprocal. Does anyone know why? It's okay if you don't, because very few teachers show why. Some of you guys are like, I don't even want to know. Do you know? Sorry, you were just adjusting. It's a little involved. So let me do this. I'm just going to show you this once, if anybody was curious at all. And you really should be. You should be like, don't just say this how it works. Show me this how it works, because that's my freaking job. Right? You guys semi with me? You guys, a lot of you guys are like, what is happening? Okay. So I'm going to start over again. Why does this fraction sucks. Yes?
This is like when you're dividing, you're supposed to multiple fractions anyway.
But why?
Because, well, like if you multiply 2 times 3 is 6, but 2 times 1/3 would be
2 divided by 3, I like it. So that sort of gives you a feel as to why, but this doesn't explain why it works though. You say, oh, these are equivalent, but why should they be? But I appreciate that, that's beautiful, I love it. So watch this. This fraction sucks, does everybody agree with me? This is a single fraction that has fractions in it, right? This really sucks. What's the best denominator to have? 1, right? Because if the denominator is 1, I can just ignore it, correct? And if I multiply the bottom by something, I have to do it to the top also, right? Okay, so what would I multiply the bottom by to make it 1? I want the bottom to become 1. What would I multiply by? How would it kill the 9 when you put a 9 up here?
Oh.
How do you kill the 4 when you put a 4 down there? So you multiply by the reciprocal, right? And if you do, you have to do the same thing to the top. Isn't that what we put there?
We just.
So this is a shortcut
Yeah.
to this. I don't know if anybody's ever seen that. Personally, I always hate it when a teacher just says, that's just the way it is. Have you ever had a teacher that was like that? My job is to explain to you why things work the way they do. Right? You never have to sit there and go, well, that's what the hell this guy wants from me. Shit, all right. Right? Maybe? No? All right. All right. I don't know what got me off on that tangent. Oh yeah, that problem. Okay, coming back to this problem. This problem is a little more complicated because now, why does this problem suck even worse?
There's subtraction and variables.
Yeah, not only are there fractions inside of fractions, there's also the subtraction of fractions inside of a fraction. Holy crap, right? So the problem we just did, there was one fraction up top, one fraction on the bottom, correct? Couldn't you, how do you, no? In general, how do you subtract two fractions? What do you have to make sure is true first? Like the nomenon, right? You guys with me? This one sucks a little bit, but if you know the process, it doesn't matter if there's a number or a letter. What is this first guy missing that he's got? A y. So you multiply top and bottom of y. What's this guy missing that he's got?
X.
Multiply top and bottom of x. Then they both have the same denominator. Put them together. Then you can multiply by the reciprocal. That's all I'll say. I want you guys to try it. Now they have a way forward. Does that make any sense?
Yes.
Okay. There's another way to do this, but let me just stick with that. That's good. So if you, anytime you have a different way to do something than what I showed, just show me. There are multiple ways to do a lot of things. And I'm wide open to a lot of other ways to do things. Okay. Yes?
You did it like wrong. Or maybe sure.
After class.
Alright.
Yeah, okay. No worries. Anything else from homework or generally? Yes. Oh yeah, so we'll talk about that. Yeah, that's a standard classic. Number 70 was like a weird little. Number 70, believe it, does this make sense? It's called a complex fraction. I don't know if I said that earlier. Huh?
Thank God we don't do 69.
Oh. Okay. 69 actually, to tell you honestly, is a little easier than 70.
What? Okay.
Believe it or not, you just put the top together, like we just said,
Oh,
and then you
yeah.
multiply the reciprocal, and a lot of shit cancels. Yeah. So 69 and 70 exactly the same. All right. Okay, so let's do this. I have this. I had it with me yesterday, and I just forgot to give it to you. Let me just give this to you, and then see what you think. So yesterday we were focused on factoring, because factoring is huge. Factoring is everywhere. Factoring is all around us. Now, real quick, just to try to make sense of this, you don't have to ever look at this again if you don't want to. It's just something I thought might help. It's going to make this more interesting. Oh well. Oh, poor little Jude is still waking up. There he is. So at the very top is just a quick reference. So you always try greatest common factor first, always. Then it's just 4 more terms you do grouping like we did yesterday. 3 terms you do, I didn't tell you what the name was. Do you remember when we found the factors and we split the middle term up? That's called the surefire method. I didn't name it. That's what it was told to me. Surefire. And then the last one is a 2 terms. So last time we talked about difference of squares, and we just started talking about cubes last time. Okay. I think I'm gonna do this. We might do a couple of these real quick, but I'm gonna kind of give you the answer key for this, I think, instead of just doing all of these today. Because it's gonna be a little bit on you. If factoring is really rough for you, you wanna focus on it a bit right now, because it's gonna be everywhere. Really make sure you understand. There is one problem I forgot. Don't let me forget. The one somebody asked me and I told you, hold on to it. It had negative fractional powers. That was okay. Bring that up in a minute. Okay. So this is just for you guys. Let's really quickly run through a couple of these things. We'll do a few problems. We'll do that weird one from the homework. So let's start off nice. What about this problem here? to remind you guys, what do you always try first? Yeah, is there a greatest common factor? Yes. So what can you take out? Thank the God. A 3, right? That's better. Because now the inside, why is this all of a sudden a much better problem? Because what's the first number inside? A 1. First number, 1. Which means that should be relatively easy. I need two numbers that multiply by 4, add to be -4. Right? What would that be? What multiplies by 4 adds to be -4? 2. Sure? Yeah, they both have to be negative, so they add to be -4. So that's done. Yeah, so that's why you do GCF first. Yes?
Why is the 3 still there after dividing
Why is the what now? Sorry?
it? The 3.
If I said factor this, and you said, okay, it's 3 times 6, so let me write 6. Is that right, what I'm doing so far? Am I factoring this correctly? No, because there should be a 3 there, right? So every step I'm at, I should be able to multiply it back up to where I started. If you lose the 3, is that true? That doesn't multiply to be this, does it? Because you're saying, why is the 3 still here? Because it's a factor. You can't just make it go away, right? Now, if this was equal to 0, you could divide both sides by 3, and it's gone, but it's not equal to 0. Okay. Cool, so you can't lose anybody. You got to bring everybody for the ride. Okay, I like it, I like it. What about this problem? How many terms are there? 2. So it could only be squares or cubes. Which one is it? Squares, because I can cut everything in half. I love it. So then you do it. 4y squared cut in half. 2y, 2y. Because now together they make a whole, dude. 9 cut in half. Multiplicative. 3 and 3. And then what do you put? Why do you put minus plus? 2 reasons I like it. So that they multiply by -9, and also so the middle terms cancel, because there is no middle term here, right? So they must have canceled, yes? I like it. See how this stuff makes sense? Hopefully. Okay. All right, so that's done there. What about, let's do a little more interesting problem. What about 8x squared? I'm going to build this up. Give me a second here. Oh, this is going to be interesting, Jeff. Let's see. Yeah. Okay, so let's say, yeah, I like it. Hey. Does anyone remember, first off, what do you always try first? And you're hoping to God that 8 comes out, because then it'll be nice and easy, and unfortunately, ain't a damn thing comes out. So who remembers what to do since that 8 is there? Yeah, we have to eventually get the grouping. To get the grouping, I need 4 terms. So I'm going to break the middle term. Real quick, I want this to make sense. How many ways can you write 2 numbers that add to be -2? Isn't there like an infinite number of ways? 3 and -5, 4 and -6, right? You can just make that list go forever. The only way that will work, that will make the grouping work, is what we're about to do now. What are we about to do? 8 times 15, -15. What is that? -120. So ready with me? So when the first number is not a 1, you have to take it into account. When the first number is a 1, you say a little like, thank you. Then you do it, because then all you have to worry about then is the numbers to add, and then you're done. When the first number is not a 1, that sucks. It'll mess everything in the middle up. So does it kind of make sense that we first bring it into account? What are 2 factors of -120 that add to be -2?
-12 and 10.
Yeah, 12 and 10, and of course I did this in my head, so I came up with something easy. Negative 12 and 10, is that? All right. And again, the more familiar you are with numbers in general, the easier this is going to be. Let me try this. All right, let me do this. I should have done it this way. There's a lot of factors of 120, correct? There's a lot of factors of 120. Let me see if this makes sense. What two things do I need the numbers to do? Multiply to be negative 120, add to be negative 2. Let's start with add to be negative 2. 4 and negative 6, don't they add to be negative 2? Then I check, do they multiply to be negative 120? No. So then, okay, what about 8 and negative 10? They add to be negative 2, correct? Do they multiply to be negative 120? No. So do you see how eventually I'm going to get to negative 12 and 10? You never have to do the products first. You can actually start with anything that adds to be this and then check to see if it multiplies to be that. I don't know if that makes any sense.
I have a question.
Yes.
What's the difference between this problem and the first one? Like, why do we do this different?
What were we able to do in the first step here? There was a 3 here. Didn't we take it out?
Yeah.
What is there now? What's right here? There's a 1 here now, right?
Yeah.
So when the first number is a 1, this is just able to be x and x.
So you don't just get like the 8 out the parentheses, right? You can't.
Can you? Can you take an 8 out? Does 8 go into 2 and 15? Can you take an 8 out? See how 3 goes into 12? Yes?
Yeah.
So we were able to take it out. Can I take an 8 out here? No. I could if I wanted to make really gross numbers, right? Okay. I really want to, and to be really honest, right here, does somebody remember, didn't we find two numbers that multiply to be 4? And added, what's 1 times 4? 4. So when there's a 1 out front, when I multiply, it stays the same. So we actually always do that. It's just if there's a 1 out front, this has to be x and x. There's less unknowns. When the first number is not a 1, shit, we got more unknowns. We have to do it a more systematic way. Okay, so these don't get there. So now I can rewrite this 8x squared. I can break up the negative 2 as negative 12x plus 10x. And then I can rewrite minus 15. Yeah. Now the reason we did this is, like you guys said, I want to be able to group, because grouping is relatively easy. And now that I've made this 4 terms, and again, just remind you guys, I could have put negative 4x and plus 2x. That would make negative 2, but the grouping would not work. These are the only numbers that would make the grouping work. So what comes out of the first 2 here? 4x. What's left? 2x. Minus 3. And then what comes out of these 2? The really cool thing is, you know, the second guy's got to be the same. So if you're like, I don't know, just look at this. Oh, a 5 must come out to make that a 2. And then 5 goes into negative 15, negative 3. Sweet. And then the last step.
4x plus 5, 2x minus 3.
We just effectively factored a 2x minus 3 out, right? So you cannot do the last step unless these two are the same. If these two are not the same, most of the time you made a sign mistake, right? But sometimes it's just not factorable or something. Yes?
So then is that just the answer?
That is it, yes. It's not equal to 0, it's not an equation, right? I always find it funny when students, once you learn to equal it to 0, you like make everything in the universe 0, which I always think of as being very nihilistic. Everything is 0. No, it's not an equation, don't make it become 1. You're done. If this did equal 0, then I would set each one of these equal to 0. I get 2 fractional answers, then I would be done, right? Okay, let me stop for a minute. This is basically what we did yesterday. All right. So, coming back to cubes, because I didn't spend too much time on cubes. Let's try a little bit more funky one. Let's see, 8w cubed plus 27. Now, real quick, little side note. How do you factor x squared minus 9? Don't even write this down, just tell me. Yeah. How do you factor x squared plus 9? You can't. Somebody's about to answer. I'm like, no. You can't. Why does this work? Because of the fact that that's a negative. These are allowed to be different signs. Then they cancel in the middle. If that's not a negative, they'd have to be the same sign. Then the middle would never cancel, right? So if you think the answer is x plus 3, why are you so wrong? Because 3x and 3x is 6x. And there isn't a 6x. What if it's minus 0? Same thing. Let me blow your mind a little bit, because tomorrow we're going to talk about something interesting. You cannot factor this using real numbers, but you can factor using complex numbers. Yeah, yay! So, I got a cool little video I found a long time ago that's, I think you'll like, that talks about imaginary. You remember, it's a very unfortunate name, imaginary. At one point in time, when people first talked about negative numbers, there were other people that were like, that's insane. How do you have a negative apple? You know, like, I've got 2 apples. If you take 3 apples away, I have negative apple. And like, what the And now we all know, like I said earlier, negatives unfortunately make sense. Like with bank accounts and such, right? So negatives are not imaginary. Unfortunately, I tried to tell the bank that and they wouldn't listen. Anyway, so we'll talk about complex numbers tomorrow. Right now, we cannot factor this. Okay. But cubes, you can factor a difference and a sum of cubes. Why does that work? Real quick. I know. A lot of side shit today. What's the square root of 4 again? 2. What's the square root of negative 4?
2i.
Beautiful. 2i. But right now, since we don't officially know complex numbers yet, the answer would be not real. Huh?
I said, oh, she brought out the I.
She brought up the I, she
Forgot
did,
about
so
the
I'll
I.
put that down there. This is tomorrow. So right now, you could put the answer as not real. Chapter 2 is where we talk about complex numbers. That is not real, because if you thought it was negative 2, what's negative 2 times negative 2? Positive 4, right? So you can't multiply something by itself. You can't multiply a real number by itself and come up with a negative answer. Okay. How many of you guys remember complex numbers, the I stuff? Anybody? So the rest of you have no idea what that is? The complex numbers, I stuff? Y'all like looking at me like, I might. All right. It's really not, anyway, we'll see. It's one of my favorite things. We'll talk about it tomorrow. And you're all like, sure, Jeff, that's your favorite thing. Whatever. Okay. What about the cube root of 8? What's that?
2.
2. What about the cube root of negative 8?
Negative 2.
Negative 2. Why does that work now? What's negative 2 times negative 2? Times negative 2? Negative 8. So if I have 3 negatives, the answer is negative. If I have any odd number of negatives, the answer is negative. So do you see how cube roots are more relaxed? They're like, I don't care. You could be negative. You could be positive. Square roots are like, oh, shoot. We'll be positive, right? Or else shit gets really unreal, man. Okay. Bad job. I don't know. So you can only factor a difference of squares with real numbers. But you could factor a sum or a difference of cubes because cube roots and such are really laid back, right? Anybody remember if you see it's a cubes, what you put down? I'll get us started. A little dude and a big dude,
Oh, yeah.
right? If you notice, and how do we know this is a cube? So how many terms are there? How many terms are there? 2. So it could only be squares or cubes, and I can cut everything in thirds. It's cubes. Little dude, big dude. Immediately put little dude, big dude, right? Cut everything in thirds. What's 8? Cut into 3 pieces.
2.
2, 2, 2, and what's w cubed? W. So it'd be 2w times 2w times 2w. Is that cool? I just broke 8w cubed into 3 parts, right? What about 27? 3 times 3 times 3. Go with me now. Everybody hates cubes factoring cubes because it's the only one that you have to kind of memorize shit. Everything else you can cut in, blah, blah, blah. So here's how this works. Little dude, little tiny dude, he takes 1, 2W, same sign, 1, 3. I'm going to put right here the other two 2Ws. 2W times 2W is 4W squared. Do you see how this times this is 8W cubed? Right? You guys see that? So if I put 1 in the first dude and 2 in the second dude, when I multiply, I get 3, which is what I had to start with. So over here is going to go the other 2 3s. Anybody remember what goes in the middle?
Where's my two? So it's the +3, but it's the opposite.
So it's got to be the opposite sign because its job is to cancel shit I don't want. Product of these things. Yes,
Where'd you get the first +3 from?
from here.
Oh.
Same sign, one of these. So where did I get the 2W from? One of these. Where did I get the 3 from? One of those with the plus, and then 2 of those, 2 of those. Now watch this. I don't enjoy mnemonic devices too much. Yes, sorry?
So the 6x comes from the first parentheses.
This middle guy will always be the product of these two.
Okay.
Opposite sign. So watch this. Same sign, right? Same sign. Opposite sign. Always positive. What does that spell? Soap. And remember what I just related this to is this Pulp Fiction where the guy had to come clean up the back seat of the car. It's the cleanup guy. It's the soap and blah blah blah. Okay, sorry. Again, bad joke. I don't care. So people do hate cubes, and I don't blame you because it's the one form you actually just sort of have to memorize where to put. But watch this. There was 3 of everything, correct? 1 of each, 2 of each, product in the middle. That's the closest thing to a song you'll get from me. Okay. All right. So you've got that factoring worksheet. Let's do this. Let's try 2 of these out. Let's do this right away. Did anybody identify a problem that's a cubes?
3.
3 or 4.
3, 4, or 6.
Look at number 4 very carefully. What makes something a cubes is if there's 2 terms and everything can be cut in thirds. Can you cut everything in number 4 in thirds?
No.
Look at it number 4 again. What do you always try first?
Greatest common factor.
Is there any greatest common factor in number 4?
Okay.
Totally. All right, let's do number 4.
Yeah. 4.
Do number 4. If you don't want to, don't do it. Just sit there. Do I have a writing pencil? Got it, right? Okay. Just to remind everybody, we just said number 4, the first step is GCF, right? Why is it not a cubes? Because they can't cut 50 into 3 parts. Oh, Jesus. All right. So what are you guys able to take out of this thing? A 2 and an x. I like it. 2x comes out. What's left?
4x.
Man, my x is really weird looking. Too bad. 4x. Let me try this again. That looks gross. 2x comes out. 4x. How many x's were there?
2x.
There were 3. We took 1, so now there's 2. Okay. Good. 50 divided by 2 is 25, and we took the x out. Now, are we done? Yeah, the trick is, I said completely. Isn't this still something? What is this? See how the 2x comes for the ride? Can't just lose him. So this is just the squares, right? So cut it in half, minus plus or plus minus, however you like it. And now you are done. Yay! So let's try real cubes. Let's try this one, number 3. So I'm giving away the game there. That is a cubes. Just to remind you guys, if you're having a lot of trouble with factoring, this is a worksheet you can bring with you to the Math Study Center. You can sit down and work with the tutor. They have other things there, other factoring practice stuff, right? Obviously, you can come to my office hours, because after we're done with this problem, we're going to move on. Catch up to you guys. How do you break a cubed up? 8 times 8 times 8. What about 8? 2 times 2 times 2. So the little dude gets one of each. What's the sign that goes there? Good, same sign. These two A's go here. These two 2's go there. That's always positive. So what's the middle of the big dude? Yeah, minus, opposite sign, 2 times A. Unless there's a GCF you missed, you can never factor the big U. It's kind of nice. You guys understand what I just said? Don't even try to factor the big U. It's never going to work unless there's a GCF you forgot to take out.
Why is there a negative 2a if there's only 3 a's? Because I'm gonna be good.
This middle dude is always the product of these two things.
Oh, right.
Always, yeah. One of each, 2 of each, product in the middle. Okay, I like it. And again, I understand. I try to teach students not to memorize too much. This is one thing you sort of have to memorize a bit, right? Everything else you sort of sink your teeth into. Find 2 numbers that do these things. Cut everything in half. This is the one you got, okay, let's go there, right? Maybe? All right, so I am going to do an answer key for this. And in the meantime, you guys can either work on this if you want to. There's plenty of problems in the homework to do. It sounds like I'm wrapping up. I'm not. We got more shit to do. I'm wrapping this up. Okay. So you got this as one more resource if you want to go get some help with factoring. Obviously, you can keep asking me questions from homework. That's factoring stuff. So let's, I think we did a lot with rational expressions earlier. There's one idea we haven't done yet, which is the most basic idea. What's one of the most basic problems I can ask you related to fractions? Even more basic than adding, dividing, whatever. What would the question be for this? Yeah, exactly, right? So real quick, help me out. How would you reduce that thing? I like it. So I'll do something we hardly ever do. We never show this step, do we? But that's basically what's going on, isn't it? And I did this earlier, but I'm doing it again. So if I factor the top and I factor the bottom, why exactly do the force cancel? The operation of multiplication and division is the opposite. So things will only, this sounds so funny to say, things will only cancel if you're doing opposite operations. I always get people that have, like, here's one thing I get. Don't even write this down. I get somebody and I say do this and they'll go, okay, these cancel. Yay. What's wrong with that? Why don't those cancel? This is division. This is, those aren't opposite operations. Do you guys understand what I'm saying? So if you're canceling something, take us and go, wait, are the operations opposite? That's the only time they'll cancel. That sounds so weird, but this is a lot of people's mistakes. Is your brain goes, yeah! And then you're like, no brain, sorry.
So in there you just cross multiply?
Yeah, so here, no. What was it again, sorry? 4/5 minus
Sorry,
5/7?
revenue.
Here you would do LCD.
Okay, so you flip and then.
Let me put this to rest. You ready? So this you just get LCD and put them together. Is that cool? Multiply this guy by 7, multiply him by 5, blah, blah, blah. Right? The only time you directly just cross multiply is if I have a fraction equals a fraction. Then you can cross multiply. Real quick, just because it came up. Cross multiplication is a shortcut. How do you kill the 2? Don't I multiply both sides by 2?
Yes.
How do you kill the 15? Don't I multiply both sides by 15?
Yes.
So here the 2 cancels and the 15 looks like it just came up. Here the 15's cancel and the 2 looks like it just came up. So what's your shortcut? Cross multiply. That's why that's the only damn place that cross multiplication directly works. So don't do it anywhere else. Okay. All right. All these shortcuts get us in trouble very often because we don't know what they're shortcuts of. So here the 4's cancel. That's ground shaking. I know. So appreciate everybody remaining calm. Now, what if instead of nice numbers, I had beautiful polynomial expressions? Sorry. And you're like, I would call it something different. Now let me see if you guys understand this. Why could I not reduce those? Doesn't 3 go into both of those? Right? Doesn't 3 go into 9, 3 goes into, it's correct? Why can't I? What's the operations? Subtraction, not the opposite of division, ain't gonna cancel. You guys with me? And again, and here, don't those, I can just cross those out, Jeff. It gets so much better. Yeah, but you get to the wrong answer quick. Does everybody understand what I'm saying? I understand. Our brain just goes, let's just get this done. Just cross this shit out. But no. So what did we do up here? What did we do? Did we factor and then kill the factors? All right, we do the same damn thing. So I want you to, and let me say this. I've already said something about this. The first 2 chapters, a lot of shit in there. There's a lot coming at you right now. Do you guys feel like that? Am I throwing a lot at you? Yes. This is the review time. Things will settle down. It won't be like bam, 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 bam this whole semester. You with me? These first 2 chapters, there's a lot in them. And I got to bring it back up in your brain. Variables, what are they? What are variables? What are you? No, what are variables?
They're numbers? Like these.
Yes, good. Variables are numbers we don't know yet, correct? Isn't that what a variable is? When you solve an equation, don't you eventually figure out what the hell the variable is, right? Variables are just numbers that we don't know yet. Whatever the hell numbers do, variables also do, because variables are just numbers. So the exact way we did this problem is the exact way we do this one. How do you factor the top? It's a beautiful, nice little thing, right?
X plus 3, X minus.
Yeah, x minus. I love it. Difference of squares, cut it in half, plus minus. But don't say anything. Take a second and see if you can factor the bottom. Don't say anything. Just factor the bottom for me. Whoop. Hold on to that. I don't know if you guys are doing it in your head. There's a lot of you not writing anything. Or have you already done the problem? Maybe you already did the problem. I'm sorry. Okay. If you already did the problem, just hang out. So I need 2 numbers that do what? Add up to 2. Multiply it negative 15. What are those? What are those? All right, so minus 3 plus 5, right? So now we can do the exact same thing. Now we never show this stuff. We have to show it here because things just got a little freakier, right? What happens now? What can I do?
You get rid of the x.
And why am I allowed? I wasn't allowed to cancel these, yes? But now I'm allowed to cancel shit. Why? Because this is multiplication, division, they kill each other. So then I just get x plus 3 over x plus 5. Give me. This is all you do is deal with me. Just deal with me for a second. Sorry, is there a question about that? Yes.
How come cancel the negative 3 and not the negative 3 and
Let me ask you this. If I had 2 times 2 times 5 divided by 2, can you tell me exactly what would happen? 2's would cancel. All right, so I think I wasn't sure which way your question meant. So one way your question could have gone is that 2 can only kill 1, 2. It can't kill more than 1, 2 because it's dead already itself, right? The other thing, I think your question more was like, why did I cancel these and not these? Is that true?
Yeah, like the positive and negative.
What's the only, why did I cancel the 4s and not the 3 and the 10? Why did I cancel those? Because they'll only cancel if they are the same, right? So these are not the same, but these are. Is that cool? Now real quick, remember when we did this? If x was 2, and you can come up with any number you want to, except for a couple. Real quick, let me ask you this. What 2 values could x not be?
0.
No, x could be 0 all day long.
Yeah.
But I appreciate it. What about 0? What can't be 0? What can't be 0 in a fraction? No. That's right. Can't divide by 0, right? What x would make this 0? 3. What x would make this 0? Negative 5. Right, good. So I can pick anything I want to for x except 3 and negative 5, because then we would make a black hole. We don't get sucked in. Don't do it. Okay. So if x is 2, help me out. What's this number here? 2 squared, 4 minus 9, negative 5. And what's this number here? 4 plus 4, is that cool? 8 minus 15. How do I reduce that? The negatives cancel, right? So you get 5 over 7. What's this number of x is 2? 5 over 7. The same stupid thing, right? So again, when you deal with expressions in x directly, you are doing an infinite number of fractions at once. Because what could x be?
Anything.
Almost anything.
Oh.
I'm with you though. I kind of set you up for that, I'm sorry. Maybe? So really, simplifying rational expressions, the more you understand factoring, the easier this is, because it's just a couple of factoring problems. And then you just kill the stuff that's the same. Are you guys okay? All right. Let me see what else I can squeeze in here. Oh, I did something I never do. I brought an outline. There we go. Of stuff I wanted to talk about. Blah, blah. Oh, okay, good. So, the next level of stuff. So one level of this is just factor, and then kill. Or cancel, if you don't like killing. Okay. If you like killing, just keep that to yourself. The other level of rational expressions, so this is going to be kind of silly, but if I had, you can do it, Jeff, 4/9 plus 2/15. How would you do that? And I'll show you kind of a nice way. I should have made worse numbers, but oh well. Let me show. How do I factor 9? Isn't that 3 times 3? Factor 15. 3 times 5, right? What do both bottoms have in common? So they got a 3. What's this first bottom not have that the second dude has? A 5. So I've done this before. What's this guy missing that this guy's got? Another 3, right? So now what's the bottom? What's 15 times 3? What's 9 times 5? 45. So this will be 20 over 45 plus 6 over 45 is 26 over 45. Yay! You can't reduce it. Yay! Okay. Right? It's a little different than, I think, the way most of you guys do it. Here's why I show you this way. When the numbers are easy, we don't have to do it the way I did it. You can just figure out, 15, 30, 45, 9 goes to 4. Okay, cool. You can do it that way, right? What about if I have two fractions where they're variable expressions? So what about this? 3 over x minus 3 plus 2 over x squared minus that. I desperately want you to understand that mathematical processes do not give a shit what is in the problem. So there's a process of how to add fractions. It exists, it's done. It works for every damn fraction set out there. So what's the process? Factor the bottoms, see who's missing something, give it to them. Yes, that's the process. What's the only one of these I can factor? Second dude, what's he factor like?
X plus 3
What's the first guy missing?
plus
The x plus 3, good, right? If you give him an x plus 3, are the denominators the same? You guys see that? Isn't this the same damn process we just used? Of course it is, because variables are numbers and they're going to work the same way. So now, what do I do up top? Good, 3x plus 9 plus 2 over the common denominator. And then you just combine, is everybody with me? 3x plus 11 over x plus 3, x minus 3. All right. Yes?
So normally, opposite signs would cancel each other out, so how come those two threes don't? Is it just because?
If I was combining them, they would cancel.
Oh, okay.
I am multiplying where they're involved in expressions with the variable. Yeah, they're not acting on each other. Yeah. Yes?
Why did you put the x plus 3 on the next to the first?
Why did I put it here? Are you cool with me putting it there? Okay. Before I put it there, what do I need to be true before I can combine two fractions? I need the bottoms to be the same. I need the common denominator, right? I'll stop joking. Common denominator. Are the denominators the same at the moment? No. What's he missing that he's got? The whole thing. He's missing an x plus 3. Right? So if I put an x plus 3 there, I have to multiply the top also, or else I just did something illegal. You can't, the only way to legally change a fraction is to do the same thing to the top and bottom, multiply or divide, right? I lock it. Yes?
For the answer, the denominator, can you simplify it to x squared?
You can. The reason I don't is because you might be able to reduce something. So you just leave it in parts so you can see if a part cancels. Here, I can't factor the top, so I'm done. You don't have to multiply it back out. But if you see nothing happens and you want to, I don't care. Yeah, it's the same thing. All right, how you guys doing? I know I'm talking a lot today. I don't really have a worksheet because you got a decent amount of homework on this stuff, so that's going to be a lot of practice. And the more you can get ahead in homework and bring questions, the more up to date you'll be, right? All right. Next idea. I think this class is done at 10:35. Yes.
Mm-hmm.
Okay, thanks. I mean, somebody could have been like, no, I think it's 10:15, Jeff. So everybody got this here?
Yes.
Okay. And again, We're getting to know each other a little bit, obviously. I just met a lot of you guys for the first time ever. It's my job to tell when I need to stop taking questions and move on. So never feel like you're gonna slow me down if you're asking a question. Does that make sense? If I need to continue, I'll say see me after class, right? But don't ever hold back on asking questions. Okay. Next idea. So we did factoring. We did rational expressions that uses the idea of factoring. Next idea today is radicals and radical expressions, really. So the very first thing I want to ask you is, do you guys remember we did this before? Is there a way to rewrite the square root of x? Is there another way to write that? Beautiful. X to the 1/2. Is that cool? Because what does the square root do? Cuts things in half multiplicatively. Exponents are multiplicative. So if you put a 1/2 in an exponent, that's half multiplicatively. Bam. So my little rant is I wish we didn't even have this stupid notation because we don't need it. But oh well, too bad for me. What about the 5th root of x? 1/5. Notice how roots are on the bottom, like on plants. And one semester I had a biologist say, well, actually, Jeff, potatoes are roots and they're on the top shelf. Most plants, roots are on the bottom. Look at one geek making fun of another geek. Say again?
The roots are on the top of the potato.
Potato is a root, if I remember correctly.
Yeah.
Yes?
Yeah.
So they're on the, so there are some plants where the roots are on the top. Let's let that go. This is not suddenly biology class. I'm sorry. They're like, well, actually, the tubers, which is what, stop. I'm sorry. On most plants, roots are on the bottom. So roots go on the bottom. What about the 5th root of x cubed? I would write that as, what goes on the bottom? 5, because that's the root. Power's powerful, it goes on the top. Just to really prove it to you, are these two things the same? What would you do with these powers? What's x squared to the 4th? You multiply. What is 3 times 1/5? 3/5. What's x to the 1/5? The 5th root of x with the 3rd power. Is everybody with me? So roots are on the bottom, powers are on the top. So how would you do this? You're all like, I wouldn't. I would erase it and hope you didn't notice. Right? I love it. Somebody actually told me one semester, he said, yeah, I noticed you sometimes missed when people don't do, so I'm just going to skip some. And I'm like, I'm going to grade the shit out of your homework.
Why
I
would
ain't
you
gonna.
tell me that?
I don't know. I'm like, keep that thing to yourself, dude. By the way, don't test that out. You're gonna fail. Okay, this is weird as shit. If they were the same root, I could combine them. Are they the same root? No. Don't we have a way to rewrite this though?
Yes.
What is it? X to the 3/5. How do I rewrite this? What do I do when I multiply things with like bases? What do I do with the powers? What's x squared times x to the 5th? You add them, right? So you have to add those powers. They happen to be fractions. Oh well. Let me see if you guys can handle this. Remember how I just said a minute ago you can only cross multiply when you have fraction equals fraction? That is very true. However, do you see how the bottoms have nothing in common? Watch this. 6 plus 5 is 11 over 10. 6 plus 5 is 11 over 10. Because how would you add these powers when you have to get an LCD? What would you multiply this one by? 2. 2 times 3 is 6, okay. What would you multiply this one by? 5 times 1 is 5. And then you would add the top. 6 plus 5 is 11, right? It's a little shortcut. If you didn't understand it, never use it. Because you just add the damn fractions, right? We should know how to add fractions, but I'm trying to show you a little shortcut. It's not really cross multiplication, but it's sort of related to it. You guys semi-okay? So root notation sucks. When it's like this, I don't know what this shit to do with it. If I put them in fractions, okay, now I can deal with that. Another reason why I wish root notation didn't exist, but too bad for me. Okay, I like it. We're almost there, by the way. Get your second win. We're almost there. It's almost over. Now, what about, let me see what you guys think about a few other things. We talked about this idea already, this idea of simplifying radicals, right? So what about this? Let's start off with a nice one for once. Let's see what that feels like. Can anybody tell me what is 2 square root of x plus 5 square root of x? You know this. I have 2 radical x's plus 5 radical x's is 7 radical x's. Okay, sweet. Is that cool? Of course it is. Just like 2m plus 5m is 7m. 2 stuff plus 5 stuff is 7 stuff, right? And maybe. All right, what about this? The square root of 8 plus the square root of 50. Are those the same? Can you combine them then? No. This is sort of like x plus y. Do you guys see that? They're not the same, so how in the world are you going to combine them? Can you do something to the square root of 8? You can break it up, right? Break it up into what? Square root of 4 times square root of 2. What can you break square root of 50 up as?
10 and 5.
10 and 5, I love it. 10 and 5 is a way to break up 50, are either 10 or 5 square rootable. So our goal is to break it up in a way where one piece of it, I can take the square root of it. 25 and 2, I love it. Square root of 4 is 2. Square root of 25 is, thanks everybody, it's 5. So what's 2 rad 2 plus 5 rad 2? 7 rad 2. Woo. So x plus y, we can't do shit with this to make it work. Square root of 8 plus square root of 50, they're not like terms, but we can actually try to make them like terms by simplifying them. Do you guys see that? Okay. Will that always work? Of course not. But you can try. Okay. So what about, anybody remember, all right, does everybody agree that like the square root of 7 is already a bad enough number? Would you agree with me on that? Square root of 7 already sucks a bit by himself. Nothing against the square root of 7, but too bad you got stuck with a bad rap. Wouldn't it suck even worse if it was being divided by? Does anyone remember what we do with this type of expression? Beautiful. We do something called rationalizing the denominator. So let me ask you this, a really silly question. Why can't you take the square root of 7, but you can take the square root of 9? What can you do with 9 that you can't do with 7? You can cut it in half. 9 has 2 3s in it. So fundamentally what's wrong with this is I would need one more 7. Yes? If it was the square root of 7 times 7, square root of 5, I could do that shit. So here's the great thing about fractions. If there's ever anything on the bottom that you wish was there, you give it to it. What do we wish was on the bottom? Another 7. Another rad 7 in there, right? Some of you guys are looking, some of you guys, the whole class have been looking like, you're going to start making sense now. But I really want this to make sense. If there was only another 7 in here, I could take the square root, because what's the square root looking for? Something times itself, and that's the answer, right? So I'm going to give him another 7, but the only way to do it legally is to multiply top and bottom. So on the top I get 3 rad 7, on the bottom I get square root of 49, right? And what's the square root of 49? That's right, kids, 7. Can I cancel the 7s? No. Hell no. One of them's the square root of 7, and the other one is 7. They're not the same. Yes.
You went cross because it's multiplication, because you can only cross when it's,
Yeah, let's stick with this. I'm sorry I showed you that thing earlier.
no, it's okay.
The only time you cross multiply is if you have an equation, fraction equals fraction.
Okay.
Then cross multiplication. Never cross multiply any other time. Unless that thing I said earlier makes sense. All right. So we can be creative. There's creativity in mathematics, believe it or not. I want to tell you this right now. I'm not sure how you're going to feel about this. Pre-calculus to me is one of the first places where, as a teacher, I actually teach you to play with math. And you're all like, I don't like the sound of that. One part of 176 is trigonometry. Is everybody aware of this?
Yes.
Does anyone know anything about trigonometry? You don't have to. Tell me one thing. You know a little bit? Like if I say sine.
Yeah.
Oh,
okay.
yeah.
And if you don't know, don't worry. You're fine. You're fine. When we get to trigonometry, you're going to have to understand that part of the process of one of the problems you're going to see is doing it wrong and then going back and trying something again. That's part of the process. In fact, personally, I think that's part of math, period. You try something, that didn't work, don't freak out, go back, try something else, not a big deal. And that's what I mean by playing with the damn thing, right? Maybe? So you'll see when we get there, okay. So, I'm not sure why they came to mind all of a sudden. There was a reason. Last thing I think I'm going to show you. Yeah, this has got to be the last thing. Okay. So does everybody get this? So like real quick. One more. I'll do two more problems. Sorry. What if I had 5 over the cube root of 2? It's the same basic idea. Why did I only give this guy one more 7? Because what was the root? Square root. Real quick. This root is the only one that we don't put the number in it. Why is that? Because it's the most commonly used root, and we're like, I don't want to write that much shit, so we're just going to not put the 2. With me? Cube root needs how many things inside to be doable? 3. It currently has 1, 2. How many more 2's does it need?
2.
So I call it matching the root, right? So I'm going to multiply by the cube root of the other 2 2's that I need. Don't I need 3 2's altogether, right? So I get 5 cube root of 4 over the cube root of 8. And what's the cube root of 8? Yeah, we designed it to be 2. Done. Yes?
Is it possible to just like remove the square root just the 2 when like multiplying it, right? 'Cause, like,
Oh, yeah, you could skip this step. Is that what you're asking? Because we designed it to have an answer of 2. So I'm cool with that. But I just show a little more than I would normally do. Yeah. So again, cube root can't work unless it has 3 things inside. So I'm just going to give it 2 more 2's. Now it works. Is the bottom rational? Shit, yeah. Right? I got rid of the radical.
Oh, I see.
Okay. So last problem for today. Dear God. And this one is a really exciting one. All right, so you see what to do when there's a single term on the bottom. Where am I at? Roman numeral, there I am. What if I add square root of 7 over the square root of 5 minus the square root of 2? And you have to simplify this. You're all like, no. What sucks about, if it was just this, all right, I'd multiply top and bottom by square root of 5, right? Just like we did before, we give it one more 5. If it was just this, I'd multiply top and bottom by square root of 2. I'd give it one more 2, correct? But now I got both of these damn things. So, let me see. Help me out here. Watch this. So I got this here, right? What would I multiply square root of 5 by to make it become just 5? It's maybe a weird question, but what do I, I need one more square root of 5. I need one more 5 to make it work. You with me? What would I multiply square root of 2 by to make it just become 2? Look at me, I'm writing it. Square root of 2. If I am not careful, wouldn't I also get a middle term that I don't want because it would have a radical? I want the radicals to die, so of course, what do? That. It's kind of like a difference of squares idea. So if I multiply by the square root of 5 plus the square root of 2, just the same shit, different sign, all the radicals would cancel. Does this seem familiar to anybody? You're all like, I don't even know what language you're using right now. Okay. So this is called the conjugate. Multiplying by the conjugate. I don't know if that sounds familiar to anybody. So I'll do the top. Let's see, square root of 35 plus the square root of 14. Is that cool? Right, just distribute. What do you get on the bottom? What's rad 5 times rad 5? Huh?
Wait, what did you say?
What's the square root of 5 times the square root of 5?
Oh,
5. Right? So square root of 25 is 5. So square root of 11 times square root of 11 is 11. Right? Here's another way. Isn't this half of 5? Times another half of 5? Makes a whole 5. Right? Aw. Minus rad 10 plus rad 10. That shit cancels. Minus, what's rad 2 times rad 2? And what's 5 minus 2? That's right, kids. 3. You will see that in the chapter 1 homework, that kind of idea. So now I'm pretty sure we've gone through every idea in chapter 1. And unfortunately, I didn't quite make it to chapter 2, but that's fine, because chapter 2 you guys, let me ask you this real quick. What's the equation of a line? The most basic equation of a line. Y equals mx plus b. Kick ass. So that's a part of chapter 2. Everybody remember how to graph points?
Yeah.
That's a part of chapter 2. All right. Yes, I'm sorry. No. I'm not so worried about the terminology, as opposed to just knowing when to do what. Yeah. All right, guys. So if you need to see me, come on up. Otherwise, I'll see you guys tomorrow. If you have anything to turn in, I got a stapler and everything. Turn it in,
So,
please.
why did you put why did you square the 2 here?
Oh, all right. Why does the cube root of 8 work? Because what can I do? So it's 3 2s. How many 2s do I have right here? 1. Don't I have 1 inside?
Yes.
How many more do I need? That's all. So if it was the 5th root of 2, I would have multiplied by the 5th root of 2 to the 4th. I would need 2 or more 2s. So I'd like to call it completing the root. Now, whatever the root is, it needs that many things.
Yeah, the clock is like 21.
When is the first assignment due?